Good morning, students. Today we are going to start a new chapter, chapter 8, Algorithm and Flowchart. It is totally based on planning steps required to achieve a goal. In this chapter, we will learn about the algorithm and its use, why we use an algorithm, and what language we use while designing an algorithm. Next is examples, then flowcharts. So firstly, what is an algorithm? An algorithm is a well-defined procedure that allows a computer or a human to solve a problem. For example, you want to achieve a small goal. You need to write the number of steps required to achieve that particular goal. So step by step, from step 1 till the final step, you require to write it on a paper. This set of plannings and the steps is known as algorithm.
Let us plan a picnic to the water park. What should we do?
You should know what steps are required for the activity. The stepwise instructions really help in planning the picnic.
Algorithm. An algorithm is a representation of a solution to a problem. We solve many such trivial problems every day without even thinking about them. For example, preparing breakfast, traveling to the workplace, and the likes. Let us take a daily life example. Steps to go to a picnic. Step 1. Make an announcement about the picnic. Step 2. Write down the names of the students who want to go for the picnic. Step 3. Book tickets. Step 4. Prepare your bag. Step 5. Travel to the picnic spot. Step 6. Enjoy the picnic. Step 7. Return back to home. Rules for writing algorithms. There are some guidelines for writing algorithm. Give statement numbers as step 1, step 2 and so on. Always begin with start. Write each instruction in a separate line. Write the function of each statement in a separate line. Write stop at the end of the algorithm. Examples of algorithm. Example 1. A recipe to make tomato soup. Step 1. Start. Step 2. Collect all ingredients. Step 3. Wash and cut tomatoes into quarters. Step 4. Wash other vegetables and cut into pieces. Step 5. Fry and cook vegetables for 2 to 4 minutes. Step 6. Remove the pan from flame and set aside. Blend tomatoes in a mixer to get a smooth puree. Pass it through a sieve or strainer. Step 7. Boil 2 to 3 cups water and add 2 vegetables. Step 8. Add tomato puree and add spices to make it tasty. Step 9. Remove from flame and serve it. Step 10. Stop. Example 2. To make butter toast. Step 1. Start. Step 2. Cut 1 slice from the end of the loaf of bread. Step 3. Put the slice of bread in the toaster. Step 4. Turn toaster on. Step 5. Wait for toaster to finish. Step 6. Put toasted bread on a plate. Step 7. Spread butter on toast. Step 8. Stop. Algorithms are often broken down into smaller chunks called subroutines or sub-procedures. This is done so that they become easier to read and also because then parts of the algorithm can be reused. Thus, we can define an algorithm as a set or list of instructions for carrying out some processes step by step. Example 3. Write an algorithm to multiply 2 numbers. Step 1. Start. Step 2. Input number 1. Step 3. Input number 2. Step 4. Multiply the 2 numbers. Step 5. Print the result. Step 6. Stop. To solve any problem, you have to follow the steps in a particular sequence. Similarly, you need to write programs in computer language to enable the computer to solve any problem. Therefore, one needs to develop an algorithm before writing a computer program to solve a problem using computers. Advantages of algorithm. There are many advantages of writing algorithms for solving a problem. Algorithms are very useful in solving problems. Some of these advantages are as follows. They are easy to understand. They are easy to implement. They describe the steps that should be taken to solve a problem. They help eliminate any logical errors in our problem solving. They are independent of any computer language. Flowcharts. Flowcharts are easy to understand diagrams showing how steps in a process fit together. This makes them useful tools for communicating how processes work and for clearly documenting how a particular job is done. Advantages of flowcharts. It is usually much easier to draw a flowchart of a problem than to write the program directly. Flowcharts are an important aid in the development of the algorithm itself. Easier to understand than a program itself. Independent of any particular programming languages. It saves time while writing a program. It also saves computer time. Symbols of flowcharts. To make a flowchart, you need some standard symbols. Each symbol represents a specific type of operation. Let us learn some symbols used to draw a flowchart. Terminal box. This is also called a start or stop box. This box is used to represent the beginning and end of the flowchart. It is an oval-shaped box. It is used in the beginning. It is called the start box, and at the end it is called the stop box. Input or output box. The shape of this symbol or box is like parallelogram. It contains instructions which are used to read or write the information, that is, all input. It is also used to print out of the specific problem. Process box. This rectangular shaped box denotes computational instructions. Flow lines. An arrowhead line is used to connect different boxes of the flowchart. The direction of the arrowhead shows the direction of flow of data and information. Decision box. This is a diamond-shaped box used to represent the conditional operations for checking or applying any condition in the program. For example, if A is greater than B, then print A, else print B. Connector. If you need to connect to any other page or another section of the chart and can't draw a line, you can use a circle or a connector. How to create a flowchart? To create a flowchart, first categorize the steps of the algorithm as input, process or output. Using the boxes, connect the statements to form the chart. For example, to add two numbers, the algorithm and the flowchart would be as follows. Step 1. Start terminal box. Step 2. Input two numbers. Input-output box. Step 3. Add the numbers, process box. Step 4. Print result, input-output box. Step 5. Stop terminal box. Hots! If a flowchart becomes complicated and you can't show it on one page, then how will you carry it to the another page? Some more. The first structured method for documenting process flow, the flow process chart, was introduced by Frank Gilbreth in 1921. Let's look at some more examples of flowcharts. Draw a flowchart to send a letter by post to your friend. Start. Pick a blank paper and a pen or pencil. Write a letter. Put it inside an envelope and close it. Write the address of your friend on the envelope. Have stamps. No, buy stamps. Yes, stick the stamps on the envelope. Drop the letter into a letterbox. Stop.
Diagrammatic representation can give a step-by-step solution to a given problem.
Draw a flowchart to read the temperature and print it. Start. Read temperature. No, print above freezing. Yes, print below freezing.